Well. Now, I am making this video for those persons that are offering organic chemistry. So this part of chemistry that I want to bring to your notice is the aspect of organic chemistry, not just organic chemistry. Organic chemistry has to really do with the reactions involving organic compounds, properties of organic compounds, preparation of organic compounds, and all that. But there's one thing that students fail to understand, that when you don't know the reaction mechanism of the reaction, you might not get to understand the properties of the organic compound. So I want to look at a particular aspect, not really mechanism, but I'm going to bring in out some videos that have to do with SN1, SN2, E2, E1 reaction. But this part is actually dealing with what? With inductive what now? Inductive effect. Now, this video is of importance for those persons, especially if you are in uniben, you are writing the CHM102 exam, or in any higher institution at all, you're in 100 level and all that. This video is specifically for you. Now, for those of us in uniben that are about to write this exam, and this video is just a trick, a tidbit on what to expect on our revision class. Remember, our revision class is holding on Monday and Tuesday on this particular course. They call it CHM101 in 100 level. But for those persons that are not in 100 level, you want to really understand inductive effect as regards organic compounds, this video is for you. Now, first off, what is inductive effect, so to say? Inductive effect has to do with the transfer of electrons permanently through what? Through sigma bonds. Now, I like to break these aspects down, and at the same time, I don't want the video to be too long. Now, what is inductive effect again? It has to do with the what? Is the transfer of electrons through what? Through sigma bonds. Now, it's a permanent transfer of electron through sigma bond due to what? Electron negativity difference. Now, I would like to break it down. Due to what? Electron negativity what? Difference, or due to electron negativity. Now, so inductive effect have to do with transfer of electrons through what? Sigma bonds, and of course due to what? Difference in electron negativity. Now, you know fully well what's electron negativity, tendency of or ability of an element to attract electron to its what? To itself. Now, you are taking three things into cognizance here in breaking down or understanding inductive effect. Number one is transfer of electrons through what? Sigma bond, and of course based on difference in what? Electron negativity. Now, what is the effects of inductive effect? Like, what is the importance? Why must we know inductive effects? Now, number one, it affects the what? It affects the reactivity of the organic compound. Number two, it affects the what? The stability of the organic compound. And number three, it affects the what? The acidity of the organic compound. So you they say I'm now, I they break them down. So you don't understand, okay, what is inductive effect and why must we know inductive effect? What does it bring about? What can it cause? Now, again, you must know that there are two types of inductive effect. We have the what? We have the negative inductive effect, and of course we have the what? The positive inductive effect. Now, this negative inductive effect have to do with compounds that how will I put it now? Compounds that withdraw electrons. So for a compound to exhibit a negative inductive effect, they are what? They are electron withdrawing what? Compounds or species. So electron withdrawing compound, what do we mean that? There are some compound, for example, if I have an organic compound now, let's say arrow is an organic compound now. Now, any compound or element or species that tends to withdraw electron from the organic compound are said to be electron withdrawing. And those electron withdrawing now brings about what? Negative inductive effect. While there are some compounds that are what? Electron donating. That means they will donate electron to the organic compound. So those ones are said to have what? Positive inductive effects. Show you the same now. So we have negative and we have what? We have what? Positive. Now, this knowledge now that you have gotten, the next thing is, how do I get to identify compounds that are electron withdrawing, therefore compounds that will bring about negative inductive what? Effect? Now, this is where it becomes very, very what? Dicey. Now, let me relate it back to what we are talking about. Now, please be very, very careful that electron withdrawing compounds tends to do what? Tends to increase the acidity of the compound. So it makes the compound more what? More acidic. So that is how what? Inductive effect gets to affect the what? The acidity of a particular what? Of a particular compound. Now, coming back to what we're trying to say, how do we, therefore, from what I said, now that means those compounds that are electron donating that brings about positive inductive effect tend to reduce the acidity. Show you the get. So if you are offering CHM102, for instance, now they can say between this compound now NO2, this is nitrobenzene, and for instance, and chlorobenzene, which one of them is more acidic? Is this guy that is more acidic? Do you know why? This guy is a strong electron withdrawing group. So now I want to list out the strong electron withdrawing group and how to identify them. Now please take note that NO2 is a very strong electron withdrawing group that based on the fact that electronegativity, nitrogen is electronegative and oxygen is also electronegative. Now, cyanide is also a good electron withdrawing group because of this nitrogen and the triple bond that exists between carbon and what and nitrogen. Now again, another strong electron withdrawing group, but not that strong, is what is COOH. Is a strong electron withdrawing group. And of course, the halogens are electron withdrawing group. Now, so you can see this guy. Of course, I want to list more. SO3H. Now, these are electron withdrawing group. Therefore, they bring about negative inductive effects. Show you the same now. So they can ask you in the exam, say arrange the following according to this. One question that came out in exam question, those are writing in uniben. They said arrange the following according to increase in what? In inductive effect, or increase in electron withdrawing effect. And this is the same thing, electron withdrawing. Now, because they stated that this one is a very strong electron withdrawing compound, very strong one, followed by what? Followed by this other guy. Then we will not have the halogens, then we will not have this other guy. But this one is very, very what? Very, very strong. Now, ladies and gentlemen, now what about those ones that are electron donating? Please, quick tidbit. I don't want the video to be too long. This is just tip of the iceberg so that you understand this inductive effect very well. Now, those alkyls, let me just bring it out. Alkyls are what? Electron donating. Not just alkyls, please, any compound that has lone pairs. For example, NH2 is electron donating. OH is electron donating. Show you the same now. So any compound alkyls and compounds that have lone pairs of electron are electron donating. Now, ladies and gentlemen, if you are very fast in knowledge, now I want to bring this out quickly here, that you know that in electrophilic aromatic substitution that occurs in benzene, that we have what we call activators and deactivators. So let me just bring this out for you quickly so that you understand this thing and you move ahead. That electron withdrawing compounds are deactivators. And say deactivators are metal directors. Now we are going to bring this aspect of chemistry out in my subsequent video, but this video is just for persons that are offering CHM102 and of persons that are having difficulty in this inductive effect. Now, why electron donating compounds are activators? So it can be easy for you now to understand what are activators and what are deactivators. So electron withdrawing are deactivators, while electron donating are activators. That means you are trying to say here, Mosjaro, that methyl is is an activator, yes. That NH2 is an activator, yes. That OH is an activator, yes. But all these guys are are deactivators. Though there's a small comma here, though halogens are deactivators, but they are auto para directors. So ladies and gentlemen, boys and girls, now you can see already small tidbit on how to understand or know the effect of inductive effect, the importance, and how to identify electron withdrawing and electron donating compound, and positive and negative inductive effect. Now these are other videos I'll be bringing out in the series of lecture known as reaction mechanism. Now, for those of us that are writing the CHM102 exam, this is for you. Please do well to attend the physical class that's happening on Monday and Tuesday for those of us that are writing exam in uniben. So I'll see you in other videos like this. Thank you very much.